So hi everyone and welcome to my channel. Today we're going to continue the thing we started in the previous video. We're going to continue our generator of parser. So basically you describe the grammar of a language in a configuration file, and then it provides you a parser able to parse the text that respects the grammar that you provided. That's basically what it is. And so in the previous video we defined how to describe some sort of a grammar by first defining the alphabets. So for instance, here we are defining digits, so it's like a set of ASCII characters. So here it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but I could provide this, for instance. It's just a simple set of ASCII characters. And then you can define rules to build tokens. So for instance, here, to build an ident, I'm waiting for first a letter. So a letter is a member of the set of ASCII characters of the letter alphabets. And then the letter should be followed by an ident2. And what is ident2? Ident2 is declared right here, and it can be either a digit or a letter, followed by another ident2, right? It is like recursive. And the breaking condition is EOW, so it can be a digit or a letter followed by an ident2, or EOW, that is basically nothing, like end of word, right? So that's basically what we did in the previous video. And in today's video, we're going to try to program something that takes in input a grammar, right? Uh, and the text. And basically, it returns you a vector of a string, and the string are the token represented by the grammar, by the tokens of the text that you provided or build onward the grammar. So for instance, here I have a token that describes affectation and rest. So it is a let followed by ident, and then it can be either like the end of the line by with the comma, or equal symbol followed by indent followed by comma. So for instance, if I provide this string, I don't know, our program should return something like this array let's, then a, then equal, and then x, right? So that's what we're going to do today. So yeah, so let's dive into the implementation right now. So first, I think the example we're gonna take and build on top is gonna be the like arithmetic expressions. We're gonna try to generate the tokens for some arithmetic expressions, right? So first we should define the grammar for arithmetic expressions, so it's not very complicated. It is this. So an expression can be a value, right? Like for instance 1. Or it can be, I suppose, expression followed by an OP, followed by an expression, right? So for example, 1 plus 1 is 1, the first expression, the OP is plus, and expression, the second one is the second expression. Or it can possibly be an opening parenthesis, followed, I suppose, by an expression, and that ends with an ending parenthesis. Okay, and now we have to define value is, and a value is basically a number or an ident. In this case, it's gonna be enough. It's just like for testing purpose, so we don't care about. I should provide like minus symbol here eventually, but we don't care. And so I have also to define what a number is. So a number is gonna be the same as idents. Number, but it has to contain only digits. Here, number. Okay. And I'm gonna complete the letters, I suppose. I don't have an Emacs macro to write instantly all the letters. Okay. I think it is okay. No, I have to define the OP alphabets, so we're not gonna make this thing complicated. Let's say plus, minus, multiplied, and divide, division. I think it's good. Yeah, I think it should work. Okay, so let's try to create the grammar. So let's print, I suppose, the parser. Oops. Okay. Cargo run grammar.conf. Yes, of course. Um, okay, and it failed. Invalid name. So let's take a look. I think all the names are correct. What is invalid name? Invalid name. Okay, so it can be. I don't think it is for this. Value is correct. Expression is correct. Expression is correct. OP is correct. And what is the invalid name? It is bizarre. Okay. Ah, is it because? Oh yeah, I think it is because he. Okay, we introduced a bug in the previous video. Okay, so I think it is because he's considering this opening parenthesis as the same way as this one. Because yeah, I think it is for this. Okay, so let's start the video by correcting the bug we introduced in the previous one. And I believe we are gonna start this video by correcting the bug we're gonna introduce in this one. That's how it works basically. Okay, so it's not very complicated. I just have to do something like this. Quotes will be false, right? Uh, and if C is equal to this, quotes will be equal to not quotes, right? And so here, if I have something but I'm in quotes, I want to consider the thing anyway as like a simple character, character contained into a literal, right? So it's gonna be this. And so I have to put this case right here because I also want to consider spaces as a part of the quotes, right? So I think it should work. Let's try to run it again. Yes, it works. Nice. It could be longer, but I spotted the bug very fast, very quickly. Okay, so now we're gonna try to do the implementation of the algorithm to parse a given text on words grammar. So let's introduce a function, I suppose. Okay, so we're gonna put it right here. Let's rename this one in init. It makes more sense. And here it's gonna be init. And let's introduce, how can we name it? Probably lex. Let's create a lex function. Lex. It's gonna return a vector of string, probably a result. I think it can fail. I'm gonna take itself as immutable and the actual text, right? It's gonna be a str. And so I'm gonna be able to do parser.parse 1 plus 1, right? And here I'm gonna return OK vec new. Okay. And here I want to parse. Okay, so I already thought of the algorithm. I had an idea on how I can do this with like a generic grammar. Uh, as it is a bit complicated, I think I'm not able to like code the algorithm and think of the algorithm at the same time and also speak in English and describe what I'm doing. So I already saw it beforehand. Uh, and we're gonna try to code it. So the idea is, why are you complaining? It is because it is Lex. The idea is, imagine you are reading like 1 plus 2, 10 plus 2, I don't know, right? Before reading the first character, you can't know, this actual expression is a number, an OP, and a number, right? we want to consider the 10 as a number, the plus as an operator, and the 2 as a number. Okay. But before reading the first character, we can't know beforehand what is going to be the type, the kind of the first token we're going to read. Um, so the idea, I want to have like a list of candidates, and the list of candidates gonna represent all the candidates for the possible next token. So here, as I have three different possible first token, idents, number, and opening parentheses, the candidate is gonna be a letter. That's for the idents, digits for the number, and opening parentheses. Next, when I'm gonna read the first character, one, I'm gonna propose one to letter, and it's gonna return me I can't have this. It's gonna say to me like no letter, no digits. One is a digit. Like no, it's gonna say no, one is not a letter, so I can't handle one, and it's gonna return me something like a forget me, right? And I'm gonna remove letter from the list. Um, then let's imagine the next one is opening parenthesis. It's gonna do basically the same. It was waiting for opening parenthesis, and we give him something that is not an opening parenthesis. So it's gonna return the same thing, like no, I don't want to be considered as the potential next token. So we're gonna remove it also. But when it comes to digits, um, digits can handle the one. So it's gonna say, yeah, I can keep like I can be the chosen one. Maybe I am. Um, and so after it will return me, I suppose, a new list of candidates, right? Because after the digits, after the one, we can wait for another digit. So yeah, digits, or we can wait for an operator. So it's gonna return me a new list, and the new list will be, so at the beginning we had something like this. The new list will be digits and OP. Okay, so that's basically how it's gonna work. And that's how, and then we give to each element the second letter, second character. So digits gonna return me, yeah, I'm okay, and gonna return me the same list, and OP gonna fail. It's gonna say, no, I'm not able to parse a digit. I was waiting for an operator. So that's gonna how it's gonna work, I suppose. Okay, so let's dive into the implementation. The first thing I wanna do is get the first candidates, like the initiates, the initial candidates. Sorry. So I would like to do. Okay, let's introduce a candidate struct first. I'm gonna put it, I suppose, right here. Let me struct candidates. And basically, a candidate just gonna be like a pointer to a rule, like the rule of the candidate, right? So we should have at the end of the initialization file a candidate for letter, a candidate that pointing to digit, and another candidate that pointing to opening parenthesis. And it's gonna be this. It's gonna be this. And so we want to have something like this. Impl candidates. So I have to put lifetime everywhere. Oops. And like a get candidate, I suppose. It takes a rule, an initial rule, and it returns a vector of self. And let's put it into do. Okay, so the rule I'm providing to candidate, I suppose, is like the base rule, the entry point of the grammar. Right here, the entry point is expression, but it is, in this specific case, the entry point is expression. If you're writing the grammar for something else, the entry point will probably not be expression. I just need to connect my charger. Wait a minute. Okay. So, but not in every grammar the entry point will be expression. So I have to provide something allowing me to bind the entry points. I think the easiest way to do this is to do something like this. Like we are defining a private token name to define what is the entry point, like for instance main, and then we are going to build to lex the thing onwards this specific rule, right? So here I'm saying the main is the entry point, and the thing I want to build is an expression, right? So I could do basically this. I suppose it will be basically the same, but let's keep it like this. It makes more sense. Um, okay, so and the thing I want to do is during the initialization, I have to ensure um, oops, that self.rules.contains key main because you should provide an entry point for the grammar. Here, so what I want to do is get the entry point. So entry gonna be self.rules.gets main, and let's say context. This should never happen. Main is missing. Nice. And now we can get the lists, the initial list of candidates. No, it's not what I wanted. Candidates gonna be candidates. Dot get candidates with entry, right? Okay, and let's print the candidate list. And now let's implement this thing. So I have to put debug right here. Okay, so the thing is, what I wanna do is reach, for instance, like here the literal opening parenthesis. Um, I want to reach the opening parenthesis, and I want to reach, for instance, digits, no, letter and digits. I want to reach those 3 points. This one, and this one, and they are hidden. They are like among the set of rules, but I have to reach them manually by recursively recalling back get candidates on the sub rules. So we have to match on a rule, right? And so what a rule can be, it can be all of this. So if it is an atomic, it means that it can be either an alphabet definition, an alphabet name, or a rule name. Let's put it into do for now because we have two cases to handle right here. This one is kind of easy. This one is kind of easy because we just want to return here. It is the easiest one. So I'll have to return the vector with candidates and rule. It's basically this. It's the only thing I want to return because literal is basically this. So it means I just want to return that yeah, I'm a candidate. Yeah. If I have an union, so it is rule one and rule two. I want like to call back the function on rule one and the function on rule two and return the union of of both sub rules. So how am I gonna do this? It's probably gonna be a candidate dot get candidates with R1. I'm gonna do it like this. I don't know if it is the best way. Dot intuiter dot chain with candidates get candidates for R2 dot intuiter, and I'm gonna collect, right? And so for the chain, let's have to indicate the namespace. So it's gonna be rule. For chain, it is also R1 and R2, but I only want to consider R1, right? Because, for instance, here, I want to consider this expression, but I don't want to consider the rest of the chain, right? Because the OP is basically not the first candidate. So I'm just gonna call back this thing on R1. And EOW is a bit special. I suppose I have to return nothing, something like a new vector, but we'll see later. And it is a rule, of course. Okay, so for atomic, how can I know if a given atomic is an alphabet or a rule? Maybe we could. I don't want to modify the init function to put like an indication on atomic. Perhaps okay, I have an idea. Yeah, let's do this. We're gonna provide a hash map right here. It is a like string rule. We're gonna provide a hash map, and we're gonna match on rules dot gets a name. So it can be some with uh, the rule, right? It can be the rule. In this case, it means that the atomic was a rule. Otherwise, it means that it is an alphabet. And if it is an alphabet, I just want to return the alphabet as a candidate, right? And if it is a rule, I want to call back the function. And so I have to put I have to put the rules everywhere. Let's do it. Here and here, I suppose. Okay. And I have to provide it right here. So it is self.rules. You are not compiling? Yeah, it is because it is a box. It's box rule, but it is the same. Nice, nice. Okay, so let's try to run. It should return me 3 rules, I suppose. And we made an infinite loop. Happened. So why? Oh, I think I know, and it is not good. Yeah, I have to introduce something else. I suppose when we go, okay, let's redo the execution. So first we go through the value. It can be either number or I don't, so we return the union of the two sub-rules. So number is gonna stop on digit and it's gonna return the vector with digits, and we're gonna return the same for letter with I don't, so we're gonna have a vector with 2 element digit and letter. That's what we want. It's gonna return right here, and it's gonna dive yet again in expression. And that's basically the problem. It is infinite because it's infinitely does value, expression, value, expression, etc. So we have to introduce some sort of hash sets, I suppose, containing all the things we saw, right? Um, so we could do something like this: hash sets of pointer to rule, and it's gonna contain all the things we already saw. So we don't do an infinite loop, right? So here I have to provide so, here I have to provide so, and I have to clone it because I want to give it also to the new candidates, so and so, right? And here I want to do this only if the rule already exists, right? So it is if so dot insert I suppose a rule, right? The rule that we are on. We want to do this, else we're gonna return simply a new vector. Okay. Oops. Rule has to implement a hash. It is annoying because I don't want to modify the rule. Uh, we could implement. No. It is okay. I'm gonna do something a bit weird. I'm gonna cast the pointer in a U size. Okay, so just close your eyes. Close your eyes. It's gonna be something like this rule. Okay, so I'm casting the pointer into a rule or a row pointer, and then I'm casting the row pointer into a U size. The so has to be mutable. So yeah. Okay, so I'm passing on a row button, but it is totally fine because like I am not using the row pointer to dereference it after, but only as an identifier. So it is absolutely not unsafe. But yeah, it is a bit ugly, but it is what it is. We're gonna keep it like this. I think it works. And here I have to provide a new hash sets, of course. I could do like an intermediate function. Yeah, I should. It's okay. We are a bad programmer. Let's assume we are a bad programmer. Okay, and it did not do an infinite loop, but it returns each candidate twice, and it is normal, I suppose, because basically it goes the first time into value, then it returns like letter and digits as earlier, and then when it goes to expression, it can, because we are testing like if this expression right here is contained into the so hash sets. So it goes through the expression, see the letter, see the digits, no, sorry, see the letter and see the digit, and returns a second time digital letter. And here it returns the opening parenthesis twice for the same reasons. Um, how can we fix this? Uh, I think it should not be a problem. How can we fix this? The idea would be to cause. Hmm, perhaps I could give the pointer to this rule right here. Yeah, let's do this. I don't know if it's a good idea. Perhaps we should continue to give twice the things. Uh, because, like, the letter we got by passing through the first value is not very the same. Is we're gonna tokenize it in the same way. We're gonna tokenize both in the same way, but it does not have the same representation. There is, of course, some optimizations, but okay. For now, let's keep it like this. So we're gonna have each candidate twice because of the fact that we are recursively calling an expression. It's fine. For now, it's fine. Maybe we could do some optimizations later. Okay, let's keep it like this. So let's continue. So now we want to read the letter of the text. So for C in text dot cars, I want to do for candidates. For candidates in candidates dot iter mut. We're gonna do something like this: candidates dot, I suppose, next car with C. It is basically this. And so here I have to define next car. And so next car gonna take self as mutable and the C the character. And so now what we wanna do is return something, right, that indicate me if I want to continue to be in the list or if I want to replace myself with a list of new uh, with a list of new rule, right? That's basically what I want to do. And I can also say, yeah, please keep me in the list without replacing me. So I think we have to return an enum. I want to do something like this. Match on self. Let's match on self. Let's match on self. So I can be no self the true. Sorry. So I can be atomic. In this case, it means that I am an alphabet, right? It means that I am an alphabet. And here I have to check if C is contained in alphabets. It can be also literal, right? It can be a literal, so with lit. And so here I have to check if lit is valid, right? And otherwise I have to fail because I can't be anything else. So let's panic. Or unreachable is more accurate. Okay. Okay, so what I want to do. So here I have to provide the alphabet, the list of alphabets. So it's going to be a reference to a hash map of string to alphabets. So name, I have to say match if alphabets dot get. So let's return a result of something. We're gonna see for the return type later. Let's return a unit for now. If alphabet dot gets with name dot context alphabet should be there dot alphabets that contains C. So if it contains C, I want to do something accepts as rejects, right? And here it is a pointer, right? Okay. So what should I add? First, I have to provide the alphabets, and I have to define what kind of return type I'm gonna have. So it's of course gonna be some sort of an enumeration. Let's call it like a next car result, next car response. Okay, so I can have something like failed or reject. Let's keep rejects. Um, it means that no, I can't handle this character. Kick me out the list. I can have something like keep. So it means like just keep me in the list without doing anything. Or I can have something like replace. And replace contains a vector of rule. It is the thing you have to add to the new candidates. Replace means remove me from the list and replace me uh, with this new list of rule, right? So that's what we have. And next car here gonna return a next car results, next car response. So I have to provide lifetime. The lifetime should not be the same as the one here. I should introduce a new lifetime, I think, because I will have problem. Lifetime is kind of ambiguous on this case. Okay, we'll see later. We'll see later, but I think we will have problem regarding the lifetime right here. It should not be the same as the structure because it will mean that the rules contained in the next car response has the same lifetime as self, and it makes no sense. Let's keep it like this for now, but we'll see later. So here we obviously have to respond with next car results, please. Next car response, sorry, rejects, right? I have to put everything into okay. Here I have to introduce something new. I'm gonna say like a current token. I have to introduce a new field. It is the state of the current token we are tokenizing. And like each candidate will have its own current token, right? So that's basically this. For instance, if I have a rule, like rule that is 1, 2, 3, a or number, okay? Um, when I'm gonna read a 1, the number gonna say, yeah, I remember the 1 and this one also. Okay, so they're both gonna have like in their memory the current token 1. Then they got all both gonna have 2. And then when they're gonna read a number, we say, yeah, okay, I'm done. Probably just this token is valid for me, stop. And we're gonna pass to the new token, and this one gonna be reset. And here it will continue remembering the current token, right? Okay. So let's say So current token string, maybe we could provide a new method. Uh, yeah, let's say new rule self. Oops, it's gonna be self with a rule, and current token gonna be an empty string. And so it's gonna be candidate. Oops, new new. Nice. And so now in next call, where are the errors? Let's see it later. I just want to check that I have here, the first thing I want to do is self.currentToken.pushC, right? Perhaps not. We'll see later. Let's say we're going to do this for now. And here, I just want to check if lit that starts with um, self.currentToken. So I want to do something else. I want to say uh, match. Now, if lit equal to self dot current token, okay, uh, I want to do something like accept. It means I arrived on what I am. Else, um, if it starts with the current token, I want to say a next car response keep. It means like continue to tell me, keep me in the list. Otherwise, I want to say rejects. Oops, rejects, right? Okay, I have to put this right here, and here I have to put this. Okay, uh, let's see the compilation error. Cargo check. 332. So here it is this, and I have to put. Okay, we have to match on the response. Let's put it to do. It is not. It is alphabet. Candidate should be mutable. Nice, nice. Okay, so what should we do in an accept case? So we have to return replace, right? We have to return replace. Moreover, we should somewhere, um, when should we push the current token in the tokens buffer? Yeah, we need to have somewhere a tokens buffer, you know? Like the buffers that are saving the tokens we are returning, like to build the output somewhere. For instance, right here, it is easy to see that I need to save the literal this lit right here, as the new token, right? And to say, no, I want to continue with a new token, a new empty token. But here, it is not exactly the same. I want to say, continue to build the new token, right? It is this. I want to say, continue to build the new token until I have to push it in the list. Until we find EOW, and so it means that we found the tokens. For instance, if I have to tokenize 100, when it's gonna read the first one, it's gonna return accept. Yeah, I accept the one, but I don't want to push it in the list of tokens right now. I want to continue to build the thing. Okay? When it's gonna find the zero, it's gonna say no, I don't want. When it's gonna find the zero, it's gonna say no, I don't want. And when it's gonna find, I don't know, the space here, it's gonna say yeah, right now push me. Okay, I'm okay. So we can't say when when it returns accept, I push it into the token list. So I think the easiest way to do this, as there is multiple ways to tokenize things, each candidate will have its current token and each token's list. It is something like this. I know there is a lot of way to do this in better way, but for now I'm gonna keep it like this because like it's okay to write bad code in the first time, whilst later for to optimize it. Um, okay. So next call. So if here I'm accepting, I have to say self.tokens dot push self dot current token dot drain dot collect. I want to drain my current token, like to remove the ownership and to put it in the tokens. Let's put this one in a method. So fn is going to be push current token. It's going to take itself as my table. Maybe drain, and it's going to be this. Oops. And so here I'm going to do self.drain current token. And I have to return some sort of a response. It's going to be replaced, and I have to provide the next token. So how am I going to do this? Oops. Okay, okay, so it seems to work. Here I have to return the like the new tokens. How are we gonna do this? So I think we are missing some informations. We need to know what was before us. So for instance, here we had opening parenthesis followed by expression. So it's basically a chain containing this and containing this. So here, oops, when we read this, we want to go through this. So we have to save somewhere that after this, we have this, right? So each candidate should have some sort of a, I don't know, the path, yeah. It's gonna be this. And the path is gonna be a vector of rule, right? And so here, get candidates gonna have a current path, and it's gonna be a vector of rule. Okay, so let's create an intermediate function. So this one gonna be get candidate rec rec. I'm not gonna make it as local. I'm gonna keep it like global, but I'm gonna do two different functions. So it's gonna be fn get candidates, and it's gonna only take these two. Oh yes, these two. It's gonna return a vec of self, and it's gonna call. It has to take self as no, it doesn't have to take self. It's gonna return self dot get candidate rec. No, it's gonna return self get candidate rec with hash sets new vec new rules rule. Right. And here I have to okay. So and now we get candidates. The dates I have to provide. So it's gonna be get candidate. So I have to do this. Nice. And so here I have to provide the current path. So it's not gonna be that hard. Let me think. We're probably just gonna do this current path dot push rule, right? So this thing has to be mutable. And so here we're gonna give the current path, and here too. We have to clone it here. Um, and here it should be okay. It is get candidate rec. Okay, we are like building the path. And so here I have to provide the path. And the path will be a vector through. Okay, so things are starting to be more complicated. So I have to provide current path, and the fact, in fact, I don't want to add a rule in these cases. So I'm not gonna push it here. I'm gonna push it in this case. I'm gonna push it in this case, and I'm gonna push it in. Do I need to push it in this case? No, I don't. I don't need to push it in this case. We don't want to save the union, right? We don't want to save the union. We don't care of the union. We just want to save like the chain. Yeah, we just want to. Perhaps we do want to. No, we don't want, I think. For now, let's don't push the union because I don't see the utility of this. So I just need to push rule and to push this one right here also. Or maybe I don't even need to push this one. Yeah, I don't even need to push this one. I just have to push the chains, right? I just have to put the chain. Yeah, I don't need this one. I just want to push like I just want to push something on the path if it is a chain because I only care about the chains. Okay, so let's do this. And now the thing we want to do is we want to do this. Let's introduce a method that's gonna pop the path and create the corresponding new list of candidates. That's gonna be something like pop path, right? Self.pop fn pop path is gonna take self as mutable and gonna return a vector of self. Yeah, it's gonna return a vector of self, or perhaps it's gonna directly return the next car response. It's easier. And here we want to do basically the same after having pushed the thing on the token list. So yet again, I'm not sure about this A. I think we will have some like ownership issue, no, a borrow lifetime issue, but we'll see later. So I have to do match self.path.pop if it is something um it should be a chain. uh so it should be rule chain. uh we don't care anymore about R1, but we care about R2. I have to do something, right? um if it is not a chain, if it is none, I want to do something I don't know yet. It means that I arrived at the end of the path. I should return a specific next car response. It's gonna be something like out. It means that I arrived on the top of the path. I return like on the beginning of the thing. It's something like out, and we should accept the out only at the end of the file. So if candidates return out, it means that if it is the end of the file, it is okay. So it means that the tokenization of the candidate is valid. Otherwise, it means that we have to remove the candidates. So it's like a failed, but a fail that I accept you if it is the end of the file. So if it is none, I want to return next car response out. If it is a chain, um, I want to if it is something else, this should be unreachable, right? If it is a chain, I'm gonna probably return get candidates self dot get candidates, with R2, right? So it means that here I have to have the rules, and I have to put the rules everywhere. So it's going to be hashmap string rule. It should be a pointer. So it's going to be rules. And it's going to be next car response replace with this, right? Why are you complaining? Uh, oh yeah, it is because it is not a rule. This is candidate right here. It is a list of new candidates with A. It is not candidates, it is candidates. And you still complaining? It is because rules is in first. Um, okay. What? Oh yeah, it is because this one is not rule, it's box. Box. Nice. And I think it is not get candidate that we want because basically I have to put directly get candidate to rec uh, because I need to provide the path, right? I have to provide the remaining path, you know? Like I don't want to forget the previous path. I don't want to rebuild the path from scratch. I want to keep what is above me, you know? So it's gonna be self.path and I have to drain the path and dot collect, right? Uh, it is not this. Perhaps, yeah, the path is in. So it's gonna be, and here it's gonna be hash set new, because here I don't care about what I saw in the past because I saw nothing. Okay, it should work. So here I have to provide the rules, and here I have to provide the rules, and so I have to put the rules right here. It's gonna be the same as here. And so in next car, I have to give the rules. Okay, it is not the good order. Oh no, it is just because it is box. Right? Ah, it is A. Nice, it works, nice. Do we have some to do? No, we don't have any to do. Okay, nice. Nice, 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 nice. Uh, is it enough? Ah, no, it is not. We have a big problem. We have a huge problem. So when are we pushing the token? Oh, okay, we have multiple problems. Um, yeah, because basically um, we have to here for the new candidates. I have to say like please take this current token that is mine and take these tokens that like I have to keep to propagate the memory of the candidates for the new candidate for the sub candidates, you know. For instance, imagine I have tokenized one um, plus and I want to tokenize the next thing. I have those two tokens in the memory of the first candidates, right? And I want to keep them in the memory for the candidates that's gonna come after. And then they're gonna add their tokens. And they're gonna give the new memory to the next candidates, you know? So I have to give the memory to the new candidates. Uh, how can we do this properly? I could put it into the get candidates rec, but it's a bit overkill. Or we don't care? Should we care? Let me think. Okay, we don't care. We don't care. Uh, let's assume we are a bad programmer. So it's gonna be self dot current token dot drain dot collect self dot tokens dot drain dot collect. And perhaps we should give the ownership on this function, so we will not be we will not need to do this. But if we give the ownership here, it means that I have to return something. No, it's annoying, and it's not the drain method is not absolutely not um, a long. It's not like a heavy method, so we don't care because it is just removing the ownership of the whole buffer and put it into the arguments of get candidate rec. And so here it's gonna be current token. It's gonna be a string, and tokens gonna be a vector of string. Okay, so here I have to put the same. Oh, there is a lot of repetition. The code is kind of bad. It's okay. We're gonna factorize it later. Tokens. Same here. Oops. What's the problem? I have no. Please. Nice. It is kind of long. Here I obviously have to clone. Right. Dot clone dot clone. And I have to repeat it here. All right. Okay, so it seems to work. And now when I'm building this, I'm just gonna remove the function. Yeah, I'm just not gonna keep using new. It's not useless. It's not useful. Here I have to do string new and vec new. Oh, this code is dreadful. It's okay. Uh, so new does not exist. Let's build a token like here. We don't need anymore a new method. So path gonna be current path, rule gonna be rule, and then we have a current token. We have tokens. That's it. And it is basically the same right here. Okay, and so yeah, it's what we want. It's what we want. Okay, so it should work. Like I'm saving the current memory, but it's not enough because I need to push somewhere the tokens I'm building. Like for instance here, when I'm finished to build the literal, I'm pushing it in the memory, and here I have to do the same if I need to do it, you know. I have an idea. Okay, wait a minute. Is it working? Let me think. Uh, Where am I supposed to know when I need to push? Uh, because basically when I'm reading, if I'm waiting, for example, for a number, right? When I'm gonna read the one, I can't know beforehand if after I will have to read yet again a zero and then a zero, or if I need to push the one in the buffer. One solution will be to like try to read the things and push if we fail or something like this, or if we don't. But I don't know how to implement this properly. In this way, I think I'm gonna do something else. The idea is when I'm gonna read the one, right? I'm gonna return a first list that is waiting for digits, and a second list that's gonna wait for operator, right? So this candidate will handle the case where the number is not done yet. So if we have, for example, 0 right here, and this candidate will handle the case where the number is done and we have so an operator right here, okay? And basically this one gonna push the token and this one is not gonna push the token. I think it works, and the idea is we're gonna use EOW. Like EOW gonna tell me if I need or not to push the token and like to split the thing. Uh, um, okay, so here when I see EOW, hmm. So here when I see a EOW, I want to do something. Uh, well, yeah, it is EOW. Okay, let me think. I think I'm gonna grab some water and I'm gonna think of this problem uh, with a cup of water. It's gonna be easier for me. Wait a minute. Okay, so I think we're back. I think I know how I'm gonna handle this. The idea is right here. When I'm gonna call back a get candidates rake, it's not. Yes, it is here. If I see some sort of EOW, I'm gonna return the EOW, right? So I'm basically gonna do something like this, you know? I'm basically gonna do something like this. I'm gonna consider the EOW in the same way as the literal. So literal is just returning itself. So I'm gonna return either the EOW. And so here I have to consider EOW. And EOW oops, basically means that I have to push the current token. Like it's a termination point, right? So it's gonna say um, mm, like it's gonna say because the EOW takes a C, but okay. The idea is we're gonna do something like self dot push current token. You don't want to do self dot push. Yeah, it's drain. Okay. Here we are not gonna push the C, I suppose, because we want to keep the C for the next. Yeah. We don't. Oh yeah. Okay. I exactly know what we need to do. So let's copy and paste the code right here. And here, okay, it's very interesting. We're instantly gonna do a self dot pop path, right? wanna instantly end the EOW. So it's gonna return me a new list. Uh, it's gonna return. It can return. Okay, it's gonna return a results. Let's a response equals this, and I'm gonna match on the response here. If the response is next car response replace with a new candidates, I'm gonna do something, right? I'm gonna do something. Otherwise, if it is anything, I'm gonna simply return the response without. I don't care if it is anything else. But if it is replace, so it means that I have to continue uh, with like EOW, with like the new concept of EOW. I'm gonna call, here I have to provide the rules. I'm gonna call back next car on each candidate, right? So yeah, it's exactly what I'm gonna do. Let me think, is it working? Because what am I supposed to return? So I'm gonna do for new candidates in new candidates gonna receive a C, right? Um, and here I have to return next car response replace with new candidates, right? Um, next car, wait, yes, it takes the rules and the alphabets. No, the rules are in second arguments. Okay, this thing has to be mutable, of course. Okay, and now I'm ignoring Nextra returns the results. Um, and now the idea is I want to retain, okay, and basically here I want to do the same thing as here, right? I want to do the same thing as here. I want to consider, so it's gonna be, I'm gonna copy and paste this code. So it's gonna be basically get next candidates. Fn gets next candidates, right? Uh, okay. Mm, so this thing I was in my mind. It's gonna be rules. It's gonna be a hash map. I was thinking, sorry, string and rule, and alphabets gonna be the same. Alphabets. This has to be a pointer. I maintain we're gonna have some issues with with lifetime very soon. It's gonna arrive. It's mandatory. This one is not rules, it's alphabets. And here we have so new candidates. It's a vector of candidates A. Okay, so here we want to return a vector of candidates with A, and I think that we're gonna have to face our problem right now, right? We're clearly gonna have to face our problem right now. Let's put it to do. We're gonna have a lot of problem with lifetime. It's like it's sure. It's 100% sure. So it's gonna return a result. Oh, wait. Okay. So here, self dot gets new candidates. What is the name of the function? Ah, mince. Get next candidate. Oh yeah, that's it. Next candidates with new candidates. I have to put a question mark right here. I have to provide the alphabets and the rules. And the new candidates have to be in first. And yet again, it is not a rule, it is box rule. Okay, and so here, I think the problem is here. No? Okay, I have to say, let's candidates equal to candidates gets next candidates with candidates self dot alphabets self dot rules. Okay. Why? Candidates are in first yet again. Okay, I'm okay. What's the problem? Let's do cargo check. I'm in trouble right now. It is absolutely not easy. 264. Okay, the problem is right here. It is C, so I have to provide C, of course. Of course, I have. Yeah, this thing has to be mutable. And so now here I have to provide C, and here I have to provide C. Nice. Let's implement get stack candidate. So we can have it's gonna be basically new candidates, and we want to return. Okay, so new candidates. We're gonna say candidates here. Okay, and we're gonna create a new candidate list. It's gonna be a new vector, and we're gonna return it at the end. Okay. Okay. And here I'm gonna match on a candidate, and I'm gonna say, okay, if it is Nesca keep, I'm gonna say new candidates dot push candidates. And so here it is into iter. If it is out, okay, if it is out, or if it is failed, rejects, I want to do nothing. Like I don't want to keep the candidate. It means it failed. Otherwise, if it is replace to add new candidates dot append to add, right? Okay. What is the problem? Yeah. Why did I write it here? Here it is mutable. You can fix this. And here it is mutable too. Okay. It seems to work. It seems to work. So we don't have issue with lifetimes. That's cool. Do we have some to do right somewhere? Okay. Okay, it should. It seems to be good. It seems to be good. So we are happy. And we don't have any problem with lifetimes. And it's cool. Because I don't want to deal with lifetimes. Hmm. Okay, nice. Nice. I propose to print the candidates at the end. No, we have to do one more thing. Here, when we arrive at the end of the thing, we want to retain candidates, only the candidates that can handle an out, that are at the end. Um, we want to keep all the candidates that can stop the tokenization here. For instance, a candidate that is waiting for example digit to finish to build the number should be removed, you know? Or a candidate that is waiting. What? Where am I? What? What is this? Where is my grammar? Where is my grammar? Okay, it's fine. What the fuck? Okay, I don't know why is my grammar. Oh no, but why is my grammar has been removed? What the fuck is this? And I can't even like go back. It refuses. It makes no sense. Okay. What should I do so? Uh, okay, let's rewrite the grammar. So I have to do okay, so letters A Z E R T Y I. Okay, OP is plus minus divide multiplied. Someone stole my grammar. Who did this? I'm gonna retrieve you. Okay, value is number plus I don't. Main is expression, and this is value plus expression followed by p followed by expression, and this is uh, opening parenthesis followed by expression followed by expression. Okay, I hope it is valid. Okay, let's run. No, let's write the thing. So retain. What do I want to retain? Match. I want to do a last time next car dot next car, but with I suppose so it's gonna be self dot alphabets, self dot rules, and the character gonna be like 0, like the null character. And here this just should match with next car response out. That's basically this. It should be okay though. So it's retain muts. Nice. And so here, let's print the results. Okay, I know it's not gonna work on the first try. Okay, so we have something weird. Um, we have 1 and plus 1, right? It is what we have. And the rule is EOW. So let's imagine we remove this. What will be the candidates? Oh, we have a lot of candidates. Oh no, but it is the path. Yeah. Let's remove the path. So okay, but why is the last candidate? Okay, let's print all the candidates before, right? Let's print the candidates before. So candidates dot uh, map c dot iter dot map c c dot rule dot collect into a vector, so we can see it easily. Oops. Okay, so let's print the candidates. So we have digit, letter, digit, letter. So we have 2 times the letter, 2 times the digits, and we have 2 EOW, but only 1 EOW survives, right? So let's do the same on all the stages, because it is a bit bizarre that the OP is not considered as, is the OP somewhere considered as a token? Let's see, c.tokens, c.current token. Why are you complaining? Yeah, let's clone, we don't care. It's just for debug purpose. No, absolutely not. Like we have +1 here, it means that we did not push the operator, and it's absolutely not normal because the EOWK. Ah, no, there is no EOW. Maybe I know, ah, because here, for instance, when we are on the OP, the only way to push a token on the list of rules is by finding a EOW. But the first EOW that we reach is through expression just right after the digits, right after these digits specifically. No, this one. So it's why we can't push the operator, because we have to have a EOW. So we should do this. We should do this. Let's create like a separate function. An OP gonna be an OP followed by EOW. So it means that the OP has to be considered as an operator. Oh, incredible. Okay, that's what we want. Oops, that's not what we want. See, that's exactly it. Okay, nice. Okay. Let's take a bigger example. Let's say I'm adding some digit in the first number. Absolute cinema. Okay. Okay. Let's put some parentheses. Okay, it did not work. So let's reprint the thing. No, okay. Let's try another example. Uh, if I add 1, okay, it just failed on the parenthesis case, I think. If I just put this, nice. Uh, Okay, this thing clearly works. The problem is when it comes to parentheses, it just returns nothing. Okay, so do we have something before the retaining phase? Ah, do we have something here? We have nothing here. So let's print all the states. And we're gonna put C here. Wow! Oh yeah, perhaps it is kind of big. Okay, so what do we have here? So first we have the basic lists. Okay, we have first the basic list. Then for the one character we have digit with opening parentheses in the tokens. So yeah, it's what we want. It's what we want. So this is absolutely valid. This is basically absolutely valid. This one should be correct because it tokenizes. They are all tokenizing the parentheses, right? So this one is the good one. This is not because it is the one that is waiting for an identifier. This is the one that is waiting for an identifier, but I suppose for a number. But I suppose the path is not the same as this one. This one, okay, and it is the same. Okay, nice. And here we have the one that is waiting for a second opening parenthesis. So that's very good. That's very good. Okay, so we have a lot of repetition right here. Okay, we have to do an optimization right after. Here we have a plus. So here we are keeping the one. Okay, so we keep the one here. Is someone waiting for an operator? I suppose yes. No one is waiting for an operator. It's a bit bizarre. No one is waiting for an operator. Why is no one waiting for it? Digit letter. EOW. Perhaps the EOW is gonna return an operator. I suppose yes. EOW. Okay, so the operator is here. So yeah, that's basically the both EOW, and we have the one that is waiting for an ident and the one that is waiting for a number. That's fine. And now that we got the ending parenthesis, we could wait. So we have a buffer with all the tokens and a 1 in the buffer, so that's cool. Um, ah, that's the problem. No one is waiting for an ending parenthesis right here, I suppose. No one is waiting for it. Yes, this one should be waiting for an ending parenthesis. Okay, so the EOW should be waiting for an open. We have a bunch of EOW, and one of the EOW should be waiting for an opening parenthesis, for an ending parenthesis. So let's print something else. Let's print something else. No. So let's print lits. Let's print lits. We reach only opening parentheses. How bizarre it is. Perhaps I. Okay, it still doesn't work, but it is better. It is better. Uh, okay, let's remove this. Let's remove this. No, let's keep this. Okay, so it still doesn't work, but we tokenized it well. But this thing is waiting for an operator, and it's normal that this thing is waiting for an operator, but we should have a case. So it means that this is specifically the case where this is wrapped under parentheses. No, it's bizarre. Um, hmm, okay, we have a problem. It's what we want, but it did not return out when we gave it. Um, it was waiting for an operator, and it's a bit bizarre. We should have the operator case. Okay, I accept it's normal, but we should also have the EOW case. And this is not normal. So let's see, let's see. But I'm not able to discern. Um, I have EOW. Let's print the whole thing. I should use a debugger, I suppose, but okay, it's gonna be a bit long. Okay, it's impossible. Perhaps I should use a debugger. No, I think I can fix this. Um, so do we have a EOW with you know, we have only this kind of path. Hmm. Okay, why it is not working? Uh, let me think. Is the grammar valid? Yeah, it is. Here, the valid one is this one. Let us do this. Why? Let's keep an easier example. Oh, I'm struggling. Why is it so long? It is because I'm duplicating candidates. I should not. Okay, the next thing we're gonna do is factorize this thing. Let's try to find the bug. Oh, it's so hard. Mm, perhaps I'm gonna cut. I don't know. E here I have a path, but I don't care. Yeah, it is the path where I'm waiting for an operator. It is the path when I'm waiting for a letter after an operator. It is it is the path where I'm waiting for EOW expression OP expression. It's not what I want. Letter no, it's not what I want. EOW OP. I lost the valid candidate somewhere, but I can't figure out where. Uh, hmm. Perhaps it is here. Hmm. This rule. Perhaps it is here. Okay, let's say something else. Let's try with something else. If we do something like this, I think it's gonna work. As far as I understand, it should work because I have the token that is waiting for an operator. This thing don't even work. So I really don't understand. Please, nice. Both systems are armed here. Hmm. And if I put this one here, oh no, it's normal because I'm not accepting the spaces. Oops. Okay, this one works. It is just like, yeah, it is basically when I'm finishing with an ending parenthesis that it failed. It fails, but I'm ending with a parenthesis. Why is this thing? Why does this thing refuse to work? Okay. Okay, I'm gonna like cut the video, think of the problem, and because it's become a bit annoying, and I'm gonna refill my cup of water. I'm back, and I think I have an idea. I ate an orange, and I refill my cup of water, and I know the problem. I think I know. The idea is here. Um, it is accepting if we have an operator, okay? Because after we finish to read this, right? Um, if let me just check something. Yeah, I am recording. If we when we are calling pop path for this case, it like reads the operator and returns the vector with the operator for the new candidates. But here, when we call pop pass, we arrive on nothing, so we are returning out, but we are not like keeping the possibility of end of file. So we should here, okay, let's do a test. If I put EOW right after here, it should work. I think it will work if I put EOW. Let's remove this. I think it is this. What is this example? So here, for instance, if I do this, it works. It works. It works. It works. I have this. I have this. But I can handle this, I suppose. I'm gonna do something like this. Drain if serve.current token dot is empty. I'm gonna do this only if this is not empty. So it works. It absolutely works. But I don't want to force the user to indicate this. It's absolutely not intuitive. So I'm gonna do something like this. If I reach so in get next candidates, if I reach out, I'm gonna add a candidate that happened that push, sorry, a new candidate, and the candidate's gonna be basically um, so the rule gonna be a rule EOW, right? Uh, Next, the it's not gonna work. Let me think. We don't care. Okay, we see later. The path gonna be a new vec, right? The string. What is the string gonna be? Yeah, the string is gonna be the one of the candidates. So it's gonna be candidates dot tokens. So it's for sorry tokens dot drain dot collects. The current token gonna be candidates dot current token dot dot drain dot collects, and here I have to provide also dot dots. Nice. And here I have a new candidate that is just EOW. So it's gonna accept end of like the out. I mean, it's gonna accept here it should path, right? Here it should path. That's what I mean. Nice, nice. What should I do next? Is it working? It seems to work. Okay, and now it's good. Uh, now it's good. So I can do whatever I want. As I am adding this specific end of word, it should always work. And I have an error because for any reason it keeping this thing. Wait. It is not normal. Why do I have another candidate? How can you just how can you do this? How are you still here? Why? What the fuck? So it means oh yeah. No, I don't understand. Ah, okay, perhaps I know. Perhaps I know. I'm not supposed to add the EOW every time, but only when it is needed, right? So I need to do this only if it is acceptable. Okay, no, yes, but I don't understand how this guy succeed to survive. It is not normal. How are you here? And the current token buffer is empty. Ah, it no. Absolutely no clue. No clue right here. Mm, Okay, so let's think. How is this possible? So here I'm pushing new candidates with EOW and with an empty path, right? Ah, perhaps this thing is surviving every time. Oh yeah, I think it's this. Ah, okay, I know. It is because every time I'm calling pop pass on EOW, it is surviving. So I have to introduce EOF, I suppose. Like I have to oh yeah, it is bizarre. Sorry. So here, I understand the bug. When I'm arriving on the final parenthesis, I'm adding an AOW, and it is normal. It is the AOW for this case, right? But I'm not deleting it because each time I'm finding a new character, the EOW recursively call pop path and is returning an empty vector with itself inside. So here, the thing I need to do is uh, here, the thing I need to do is if okay, so pop pass. I'm sorry. Um, if C, no, I can't do this, but if self dot path dot is empty, I have to do something very special. I simply want to return anyway out. I suppose next carry response out. I'm out if I'm empty, and if I am um, EOW and my path is empty, it means that I'm out. And now it works. And now it doesn't. Yeah, because I removed the. No, you're still here. What? I'm saying it's the orange, I think. I'm dying. Yeah, you're still here, so let's return eject and no, because and see difference of this. This is gonna be a private character for the termination anyway. Okay, so now it works. Let's try some weird example. Let's for example do this. It should return nothing. Nice, nice. Here it should work. Nice. Let's add some parentheses. Nice. I don't know. Let's do this, this. Nice. Nice. That's what we want. Okay, it seems to work. I suppose there is some bug, but we'll see later. Hmm. I forgot how to drink. Nice. So it's fine. So now let's return the results. So it's gonna be um, candidates if candidates dot len dot is empty, we want to bail in the syntax error, I suppose. Perhaps we could give some context in the future, but for now it's okay. Else, I would like to say okay with candidates 0 tokens. Nice. No? Let's say pop. Nice. Okay, so it should work. Okay, and we should be able to give some context right after. And for instance, if I do this, it is considering, yeah, it is considering 1s as no, it should not consider. Oh, what the fuck? This number. The grammar was invalid, but it's okay. Nice. Okay. Why is this thing? Okay. Number two. That's why it failed. It was not supposed to fail. No, I would like to improve the algorithm because here let's print the candidates as the length of the candidates, right? So here, for instance, we have 48 candidates. It's tremendous. And we have more candidates than we have rules. We have 1, 2, 3, 4, 5, 6, 7 rules, and we have 8 candidates. 48 candidates, I mean. And moreover, the only candidates we are supposed to have is OP digits, a letter, and opening parentheses and ending parentheses. So 1, 2, 3, 4, 5. We should never have more than 5 candidates, but we have 48. Because we are considering the digits and letter contained in this value the same as the digits and letter contained as in the value of this expression. So to improve this, I suppose we could I don't really know how to do this properly. But we could complicate a bit the candidate struct. Let's try to implement this quickly. So it's all about the path. The only thing that's gonna change is the path. So paths are gonna be a vector of path, right? And so here we're gonna say the hash set gonna be a hash map. Okay. And it's not gonna be the hash map of it's gonna be hash map of usize bounded with I suppose usize I suppose with candidates. Yes, usize of candidates. Here it's gonna return nothing, and we're gonna put the candidates into the hash map. So here is gonna be candidates. And so, okay, here we want to return nothing. And here it's gonna be something like this, candidates equal to candidates dot get much. It's not gonna be a rule, it's gonna be the rule. right? I have to put here as a reference. I want to do something. Otherwise, I'm gonna do this is a mutable reference to a hash map, right? So if I already saw it, I have to do something. What is this thing gonna be? It's gonna be candidates dot path dot push um, current path, right? Here it's gonna be a vector, and here it's also gonna be a vector. Oops. It's also gonna be a vector. And so I have to say candidates. Here it's gonna be candidates, right? I don't need to clone. And why am I not able to iterate? Because it is not an iterator for sure. So I have to, it's gonna facilitate the things. Do this. Here I have to close the parenthesis. I have to close this right here. I have to put a comma. So I'm just recalling this thing here. Here is gonna be candidates. I have to remove this, of course. Okay, it should be enough. I'm basically doing the same thing here every time. I could factorize. It's okay for now. And so I want to say let's mute res equal to a new hash map. Say mute to res, and here is gonna be res dot values dot collects. Nice. I have some issue. Where are the issue? Okay, let's say yeah, here I have to return nothing. So it means that in candidates I just have to insert on address. So I'm gonna say address candidates like this, and I have to close the parenthesis, and I have to do the same here. There is a lot of repetition. I could factorize, I know, but we'll see later. Let's try to make it work in first. Oh, yeah, for sure. It is because I mean, here let's put it here, and here it will be let's say on rule fn id, it returns a use size and it takes self. Gonna be easier, and let's put it here. It is not easy. And so here it's the rule dot id, and here it is the rule, oops, dot id, the rule dot id, and here it is also the rule dot id. It is not the rule, it's just rule, right? Here it is rule also. Mm. Okay, we'll see later. What's the problem? Yeah, I have to put a mutable. Let's say let's map equal to hash map new. It should be mutable, and let's put it here map. And I should. It is not what I want. Okay, let's do it artificially. Okay, I'm really. There is a lot of repetition in the code, but I suppose it's fine. We'll see. I think I'm gonna factorize everything in in off video. It's not very interesting. Okay, please, Emacs, write something here. And so that's it. Here I should do map dot values dot collect, and I'm gonna wrap it into the replace. Yeah. What? Ah, yes. Okay. Of course. Of course. Okay. Here I'm gonna have multiple path, right? It's gonna be because basically for path in self.path, I have multiple possibilities, and I want to return all the possibilities. Let's mute res gonna be a new vector, and res gonna append this, right? If I have nothing, it means that I'm out. So here I wanna do nothing. Let me think. Okay, it's a bit complicated. I think it's not gonna work, but I'm a bit tired because it's running late. So I think I'm gonna cut the video here, and we're gonna continue in the next video, I suppose. Uh, because things start to be a bit complicated, but um, I suppose we have something that works. Um, target.debug.gparser. If I give you grammar.conf, like you succeed to compile, like we have something that work. Look right here. That's what we gave to the thing. Okay. I don't know if in this example it's what we gave. Yeah, it is. So that's what we was looking for, but it is a bit like uh, expensive. The algorithm is very, very, very heavy, and I would like to have less candidates each for each character. But we'll see in next video in part 3. So the goal of next video is going to be to optimize the generic lecture. My idea was to go through the parser in the next one, but like the code is a bit complicated, and the video is already very long, so I'm gonna cut here. So yeah, so thank you for having watched the video. If you're still here, it was not easy at all. So yeah, and see you for the next video, I suppose.